Okay, so we're going to do part 3 of 8.3 today. So in part 3, we get to do a completely different method called the cylindrical shell method. Okay, so we're going to do the cylindrical shell method. So let's go ahead and go to page 410 and we'll do the exploration there. Okay. In the exploration, it says we are trying to do the volume of the parabola. So the parabola is x squared, 3x minus x squared. So y is equal to 3x minus x squared. So we're taking that parabola, which looks like this, 0, 3, right? 0 to 3. And we're actually going to rotate this around x equals -1. So -1 is here, and we're rotating this around like that. So you're gonna get like a half. It's gonna be like a bundt cake thing. All right, a bundt cake mold. All right. So if you look at page 410 on the left-hand side, there's a figure 8.28 there that shows you what it looks like once you rotate it. Okay? So if we were to do the washer method, right? If we were to do the washer method, we would go like this. And we will actually be doing dy here, right? You turn it around. So the outer radius would be from here to here. And the inner radius would be from here to here. Okay? The problem with this is that we have to come up with, we have to put this into x's, right? Because it's in y. So that's going to be a problem, right? That's going to be pretty tough. All right? Not only that, so it changes as it goes, right? So, you know, it becomes quite complicated to do that, okay? So what we're going to do is instead of doing dy, we're actually going to do dx here. So we're going to go like this, okay? So if you take this slat and you rotate it around, what do you get? You get a cylindrical shell, right? Not a cylinder, because you actually have an outer radius and an inner radius here, right? Okay? So we're going to have a cylindrical shell. So we're basically, what we're doing is we're nesting these cylindrical shells, okay, as you go out, okay? As you move the slat from here to here all the way through here, you're going to have smaller, then larger. You're going to have, you know, those type of cylindrical shells that are like nested like Russian dolls. They're nested one inside of each other. Okay? So let's say that this is x. This is point x, right? This is point x, right? So which means that this would be y here, right? Because it's on this here, right? Okay? So we're going to get what? We're going to get a cylindrical shell that basically looks like this. That looks like that, okay? With the outer radius from here to here being what? It's the distance from here to x, right? So this radius is going to be 1 plus x, right? Because you have 1 here plus the x. Okay? So that's the inner. We would call that the inner. The outer is going to be what? 1 plus x plus that little sliver there, right? Okay? And the height is going to be y, right? The height here would be y. Okay? So how do we calculate the volume of this cylindrical shell? All right, the way we do that is that we slice it and we put it open, we flap it open like this, just like we did when we were talking about the surface area of a can, right? It's the same thing, right? So we're going to slice it and flap it open. So we're going to end up with something that looks like this, okay? Where the height here would be what? This is going to be dx. Right? Now the assumption we're going to make here is that when dx is sufficiently small enough, we can basically say that this is going to be 1 plus x and this is also going to be 1 plus x. Okay, in other words, this here is 1 plus x, and the outer part is also going to be 1 plus x too, because dx is so small, right? So this is going to be 1 plus x, right? Well, not 1 plus x. What is it? Actually, it's 1 plus x 2 pi, right? Because this is the circumference of this circle here, right? So it's 2 pi r. So it's 2 pi times the r, which is 1 plus x. And the height is going to be, still going to be y, right? So the volume is what? The volume is y, or let's do this right. It's going to be 2 pi r, the radius, which was 1 plus x, right there. So this is that, and then this guy is going to be y, the height, and then you're going to multiply that by dx, right? Because that's the thickness right there, right? And you go from, x is going to go from where to where? X is going to go from 0 to 3. 0 to 3. Okay? Well, the thing is now we have y here, right? When you have x, d of x, so we have to put this guy into here, right? So basically, you're going to end up with, in the end, you're going to end up with the volume is 0 to 3, 2 pi, the radius, the radius is 1 plus x here, times the height y, and the y was 3x minus x squared dx. Okay? All right, so this is the circumference, 2 pi r, times the height, and then dx. Okay? Notice now, when we did the washer method, if we are rotating this way, we usually got dy. Okay? Where in the cylindrical method, if I'm going here, x, if I'm going around the x is equal to something, I'll get dx instead of the dy. Okay? All right. So now we can just go ahead and plainly, we can go ahead and pull the 2 pi out, 0 to 3, 1 plus x, 3x minus x squared dx. These are just polynomials, so you just do it out, and then it's a pretty simple integral here. Okay. Now notice again, this is a totally different way of approaching the volume. Okay. Now we're not talking about washers, we're talking about cylindrical shells. Okay. Cylindrical shells cut open in this manner, and then you're going to go the circumference, 2 pi r, the circumference times the height. Okay? So that was explanation 1. Now let's see if we can go ahead and do the example that they give us associated with cylindrical shells. Cylindrical shells, all right? So we have example number 5, and we're doing y equals root x, and x equals 4. So we're doing a cylindrical method of that. So we have, this is example, what was it, 5? Example 5. We're going to take y equals root x, and we're going to go from to 4, and we're going to twirl it around the x-axis, okay? So so we're going to go ahead, and since we're doing across the x-axis, we're going to have that, right? So this would be our dy. We're doing dy, we're going around, right? Going around, okay? So this here, if this was x, right? The height is going to be just y, right? So what do I have here? I'm going to have a cylindrical shell with a radius of what? It's going to be y, right? So we're going to have 2 pi y times the height. The height is what? 4 minus x, right? Because the height is from here to here, right? So we're going to have 4 minus x, right? And we're going to go dy. And we're going to go from where to where? Y is going to go from 0 to, when x equal to 4, y is equal to 2. So we go 0 to 2. So this is actually a much more simpler way, because we're rotating around the actual x-axis, right? We don't have that plus or minus 1 that we had in the exploration. Okay? So we're going to get what? This is going to be, pull the 2 pi out, 0 to 2, y. Now I have x here, so I have to go ahead and solve this guy for x to put that in here, right? So I'm going to get y squared is equal to x. So I put the y squared in there, I get 4 minus y squared dy. Notice one thing good about the cylindrical method is that you're not squaring anything in here, so you tend to get a little more simpler integration in here, okay? So we're going to go with 2 pi 0 to 2, 4y minus y cubed dy, 2 pi, so if I take the antiderivative of this, I get 2y squared. Over here, I get minus 1 over 4y to the 4th. And we're going from 0 to 2. So I simply put the 2 in there. 2 pi, the 2 I get here is 8. If I put 2 in here, I get minus 4. So it looks like my final answer is going to be 8 pi. And that is correct. Okay, let's do one more. Let's do example number 6. Example number 6. Example number 6. Has us doing the region bounded by the curves y is equal to 4 minus x squared and y is equal to x and x equals 0 is revolved about the y-axis to form a solid. Use the cylindrical shells to find the volume of the solid. Okay. One thing to take a note here is that this question actually prescribed you the method to use. Okay, and you will see that frequently in questions like this. They will tell you which method to use. Okay, there are some questions that will be use whatever method you want, because sometimes you can actually use both. Okay, so in this one here, let's do, okay, so we're going to go, what, 4 minus x squared. It tells us to use the cylindrical shell method. So we have, this is y is equal to 4 minus x squared. So this would be 4, 2, negative 2. And the other one looks like this. Y is equal to x. So we're going to go ahead and rotate this guy here around the y-axis. So we're going to go like this. So we're going to have what? We're going to have dx's here, right? dx. Okay, so we're going to have dx. So we're going to go 2 pi times the radius. What is the radius here? What is the radius? It's actually x. This is because this is x, right? This is going to be x, right? So it's nothing more than x. Okay, and the height is going to be from here minus this. So it's going to be 4 minus x squared minus x, because this guy is here is x. This guy is 4 minus x squared. So you take this and subtract the x. And d of x. So we're going to go from where to where? 0. We're going to go from 0 to, oh, we need to find out where that is, right? So what does that happen when these two are equal to each other? What does the book do? Does the book actually knit this? No, it doesn't. Well, it kind of does, but okay. So what do we have? We're going to put these equal to each other, so we're going to get what? 4 minus x squared is equal to x. Move this over, I get x squared plus x minus 4 is equal to 0. This does not factor out, so it's not going to factor out, so you're going to have to do what? You're going to have to do the quadratic equation, right? So we're going to go x is equal to b, or minus b plus or minus square root of b squared minus 4 times 1 times negative 4 over 2a negative 1 plus or minus square root of 17 over 2. And if you do that, you are obviously going to get 1.562. 1.562. So we're going to go from 0 to 1.562. Pull the 2 pi out, 0 to 1.562. I'm going to get what? 4x minus x cubed minus x squared dx. So at this point, it's actually just easier to nint it because you're going to have to use a calculator anyway because you do not know what 1.562 to the cubed is. So I would just nint it. And whatever we do, we get 13.327. Okay? So that's how you would do that. Okay? Example number 7 is comparing different methods. Okay? So like I said, sometimes if the question does not specifically stipulate which method to use, you can use whatever method you want. So let's go back and revisit example number 5. So if we revisit example number 5, what did they have us do? They have us did y is equal to root x, right? From 0 to 4. Y is equal to root x. So this is 4. This is 2. And we're doing around the x-axis. So we can actually do a what? We can do the disk method this way, right? Because that would be much simpler, right? Because we can just go over, rotate that disk around, right? So we get volume is going to be equal to, this is a r, right? So that's going to be squared. So what is that? This is y squared, right? So it's going to be y squared times pi. That's the area times dx, right? And where x is going to go from where to where? 0 to 4. So we're going to go 0 to 4. So pull the pi out, 0 to 4, y squared. What is y squared? Y squared is x dx, right? And so what do we get? We're going to get pi 1/2 x squared evaluated from 4 to 0. So what do I get? If I put 4 in here, this is x, right? So 16 divided by 2, so it's 8 pi. We get the same answer. Actually, a much simpler method here, right? So the lesson learned here is that before you blindly go ahead and do one way, think of the other way. See if the other way is possible. Sometimes it's possible, and you get something that's much more cleaner this way. Okay? So we'll call it done for that one.